In this lesson, I'm going to talk about data inputs, and I will show you how we can make data input hierarchies to make more complex data values for our modules and their parameters. Okay, let's see what data inputs mean, and then I'm going to go over some of different types of data inputs and how we can mix them together. When I'm referring to data inputs, all I'm referring to is these values here. These are called data inputs. For example, the noise strength for our curl noise is set to 150. This is a data input of float. This is a float value of 150 that we are using for the noise strength. For the frequency, we are using another float value. Float means that it can have decimals with it. However, when I was talking about these scale sprite sizes, for example, if you remember, I changed that number. If I reset it back to its original value, originally the scale sprite size was set to x and y equal to 1. But since we wanted to change those values over time, I changed that to a different type of data input, which was the curve or float from curve or vector 2D from curve, right? So technically what I'm doing here is I'm changing the data input from a vector to another type of data input, which is called vector 2D from curve. And all what it says is that create a vector 2D, a 2D vector out of this curve. So out of this curve, create a 2D vector. And if you remember, we started moving these keyframes around. So currently what I'm doing is I'm changing the scale x of my particles over their normalized age from 0.5 all the way to 0. And at the same time, I'm changing their y value, their scale y value from, for example, 0.8 or 0.9 all the way to 0 over the period of their normalized age. Okay. And by the way, you can see that since I'm not having the same value for x and y, I'm technically non-uniformly changing the size of these particles. This is one type of data input. So this concept of data inputs allows us to start building some formulas, some math formulas, to be able to mix different types of inputs together. Currently, I'm just using one data input. But let's go over some of them that we usually use. I made a list here for you, so you can almost get familiar with their names and what they do. And again, these are only just a couple of them. We have a whole bunch of them, but these are the ones that I usually use a lot. So the first one is the range. If you remember, we used the range for our lifetime as well as the particle sizes. This range data input allows us to create a random value between two numbers. So for example, from 0 to 5, it picks a random number anytime that it's using that value anywhere. So let's go back and see where we use that. In the initialized particle, if you remember, for the lifetime, we set it to random. And we said we want to have a random from 0.1 to 3. And if you remember, I said this data input, this lifetime mode is new. Back then, it used to be just a direct set. It was just like this, and we didn't have this drop down. So we could only use a lifetime of 2. However, even in this situation, I can change that to a range by typing a range, random range float. And technically, it's the same thing. I'm converting my constant number of lifetime, which was originally 2 or 3 or 5. I'm changing that to another type of data input, which this time is just a random range number, which allows me to pick a number between two ranges. And technically, it's the same thing as we changed that to a random. Again, since this random didn't exist back then, we used to change the lifetime to a random number using the range data input. Similar to the sprite size. So if I want to do the same thing for the sprite size, I'm going to change or convert this constant value of 2 to a range. And then I could pick any two numbers for my range to change the random size of my particles. All right, so anytime that you change any data type input, you can always go back to its default value by clicking on this default value button or undo button. So that's the first data type. The second one is multiply, add, subtract, divide, which is the primary operations on two inputs. So it's not that easy to show it directly. I'm going to use it somewhere else. Just be aware that in terms of data inputs, we can use a multiply value to multiply two numbers. Soon I'm going to show you an example that has some of these all together. We also have a curve input. We already used that for our particle sizes. Let's go back to Unreal. This is where we use that. So scale sprite size. By default, it was set to a value of 1, so it wasn't scaling anything. However, we converted that to a curve, vector 2D from curve, and then we started playing with these curves. What we care about is this curve term here. So it says that use a curve to drive my values depending on another value. In this case, it's normalized age. The next one is 2D, 3D for the vector from float. So converting one float number to create a vector number out of it. It means use one value for all axes. So let's see where we can use this. This is a nice one. So I'm going to show you how we can use this, how we can leverage this one for our purposes. Let's go back to Unreal. So if I reset this scale sprite size back to its normal value, which was a 2D vector, one of the issues that we had with this one was that when we converted that to a curve input, we were dealing with two axes. So we are using two curves to control scale X and scale Y at the same time. And since we wanted to have these particles to be always uniform in their size, to avoid having these non-uniform scales on their size, we had to make sure that these two curves are identical. We wanted to avoid having different values for X and Y. We wanted to make sure that X and Y are always the same. They're always using the same value. So to solve this issue, what we could do is that we could convert this vector to only be one value that is being used for both X and Y. So going back to here, I want to make an input that says use one float number and convert that to a vector and use that float number for both X and Y axis. Okay, so let's go back to Unreal. Before I convert this to a curve, I want to make a 2D vector from a float number which I provided to you. Currently it's set to 1. If I make it 5, I'm saying that use a value of 5 for both X and Y. So let's undo this. If I want to scale all of these particles at the same time, I need to type the same value for both X and Y. I'm going to go back to my initial particles and change the size of the particles here to something non-random so we can see the difference there. So currently in the initialized particles, all the particles are having the same size of 1. In my scale sprite size, I'm scaling them up by a factor of 3 in both axes. If I convert that to a vector 2D from float, now I'm using one value for both axes. So I can scale them up and down uniformly all together at the same time. So that's the beauty of this vector 2D from float. Now I can convert this value to a curve. So I'm going to use this new drop-down list and type in curve, float from curve. And now I'm using only one curve to drive my only value here that is driving my vector here. So let's try that. I'm going to use a value of 0 here and perhaps a value of 10 or 5 so we can see these particles. So now the particles are uniformly scaling up, uniformly scaling down over their normalized age. Okay, I'm going to explain this hierarchy in more detail very soon right after this. The next one is a make vector, which allows us to split a vector into all of its components so we can access each one of those inputs individually. Let's go back here. I'm going to just show that here as an example. Currently, if I want to convert this Y value or X value to a range, for example, I can't do it because they are both making one vector. However, using a make vector 2D input, I'm technically splitting the X and Y. Now I can type in a value just for X and a value for Y. And the beauty of this is that now for just the scale Y or just the scale X, I can write in any different types of data inputs as well. So for example, I can change this to a range. So now my scale X is always a value of 2, but my scale Y is a value that varies between 1 and 5, or 1 and 10. All the scale x's are the same. The scale y is only changing. Like this. So make vector 2D allows us to split a vector into its components so we can have access to each one of the components individually. Let's undo this. And the last one is a sine function. I will spend more time on this sine function, and I'm going to show you very briefly how we can use the sine function for some places in our particle system. I talked about these different types of data inputs, but what I left out was how to make hierarchies, or what that hierarchy means. Very quickly, I did that here when I wanted to show different types of data inputs. So let's just do it one more time. Vector 2D from float, and then I converted this value to a curve. Technically, what I was doing was I was making a hierarchy of data inputs. Let's get deeper into that now. Let's just make this our curve. So I like how these particles are growing up and down, but they are very small. And let's say I want to maintain all of this setup, but I want to multiply all of these scales by 5 or 10 just to make the particles to be a little bit bigger, but maintain this curvature and maintain this vector 2D from float and everything. So in order to do that, I know I need to multiply two numbers together. So one of them is going to be a curve, the other one is going to be a constant number. So the first thing that I need to do is, rather than directly using this curve to drive my float, I'm going to use a multiply input. This is the one that I skipped because I said I can only show that when I'm dealing with multiple values. So I'm going to use a multiply input. This allows me to multiply two numbers together. And now for one of the numbers, I'm going to use the curve, our friend float from curve. And the second one is going to give us this opportunity to multiply everything by a value of 1 or 2 or 3. So let's create or recreate our curve. And we are happy with the result. Then I'm going to multiply everything by a value of 5. So now my spheres or my sprites are going to scale up and down using this curve. And then they're all going to be multiplied by a value of 5. It will give us a number. And then we're going to use that number for both x and y values. Let's elaborate on this a little bit more and see what else we can do here. So currently my particles are not having a random size. We know how we can initialize their sizes randomly in the initialized particle by going to initialize particle and choosing different numbers for our range to make them random size. Let's assume that we do not have this. So let's assume that our particles are all having the same size of 1. Let's go back to our scale sprite size. Let's convert that number to a range. Here we go. And let's pick different numbers for our range. Let's say minimum of 1 and maximum of 5 or maximum of 10 even, to make them even more random. Again, this is just a proof of point here. Let's see what we've done here. I'm going to go back to my slides. This is what we got here in Unreal. Let's elaborate on that. So what this setup is doing is it's going to make this formula for us. And I color coded them so we can understand where we are. So we are generating a random number, in this case between 1 and 3. We are generating a number using a curve input, which is this one. We are multiplying them. And then we are using that number that we get to make a 2D vector out of it. So we are scaling up the sprites in both x and y using the same value. So this lists all what we need to have to be able to make this formula. Let's see where they are. This is our make 2D vector from a number. Then I'm multiply float, two inputs. So after I have the multiply data input, I need to give it two numbers. The first number is our curve, A. And the second number is B, which is a range already. This is what we are having currently. I collapsed these inputs so we are not overwhelmed with all of these names and terms. A vector 2D from float that is using a multiply input, and that multiply input is multiplying two inputs. One of them is a curve, the other one is a random range. Technically, we are creating a hierarchy of data inputs. Two numbers are being multiplied together to give us another number, and that number is converted to a vector 2D format. And this is the hierarchy that we are getting. So now that we learned how we can use this, I'm going to just show you one other data input that I skipped. I skipped this sine function input, and I'm going to show you very briefly how we can use that in some of parameters in our particles. Okay, so I'm going to change the size of my emitter to something smaller to make it a point. Okay, and I'm going to change the size of my particles to even lower than that, so 1 to 3 as a random number. All right. I'm going to go back to my sphere location, and the sphere location, if you remember, not only it allows us to change the size of our sphere, but also we have this offset value here that allows us to move that sphere around in this 3D space. I'm going to split this vector into all of its components by using the make vector data input. So make vector. And let's say I want to move the source up and down over time using a periodic movement or using a sine function. What the sine function does is it will allow us to create a periodic value that goes from -1 to 1 or -10 to 10, depending on the inputs that we give it. And it will allow us to actually move something over time periodically. I want to do that in the z-axis. I'm going to convert the z to a sine function. And if you are familiar with the sine function, whenever we are using sine or cosine functions, we have a frequency or period as one input, we have a scale or amplitude as the second input, and we have offset or bias for the third input. So the period or frequency makes the periodic movement to go faster or slower. The smaller the period, the higher the frequency of the sine function. The scale lets the value to go beyond -1 and 1. It allows it to go, for example, from -10 to 10 and anything. And the bias lets it to have an offset over time. So it doesn't always start from 0, 0, or it can actually start from any other offset that we give it. Let's make the amplitude to go higher than that. And now you can see that the source is going up and down. Just to make it a little bit more easier to see, I'm going to turn off the wind, turn off one of the turbulences, or even two of them, the curls. And I believe the period is a little bit too fast. I'm going to keep one of the curls here. I'm going to go back to my sphere location, and the scale is set to 50. I'm going to change the period to something higher so it's a little bit slower. I want to make sure that you can see what's happening here. So let's spawn more particles. 10,000. Okay. And I'm going to change the size of the particles to be a little bit smaller. I'm going to go to initialize particles and change this to 0.1. 0.5. Here we go. I hesitate to turn off the curl because that's the beauty of our simulation, but let's for a moment turn that off, and I'm going to turn on the wind. Okay, here's our emitter that is going up and down. So let's go back and play with the sine function. The period, I'm going to make it faster by turning down the period. So every 2 seconds, it's going to make a full cycle. Change the scale to 90, so it goes higher and lower. Okay. So I hope you can see the result now. So this is how the sine function works. Just to make it a little bit more interesting, I'm going to use a cosine function for the other axis, and it will give me a circular movement. Again, this is a math concept. I'm going to just briefly introduce the concept. So as long as the amplitude and the period are the same, we're going to get a circular movement for our source. Like this. All right, and let's bring back in the curl noise. Here we go. So just created a circular movement on our particle using the sine function and cosine function in our source. I'm going to make the particles to go a little bit larger. That's cool. In the next lesson, I'm going to talk about the render modules, and we're going to see what options we have for our particles look.